Hello, viewers. In today's session, we are going to discuss these four important limits. And here we have to find out the limits, that is, limit x tends to 0 positive, and here the function is signum of x. So here we have to find out the right hand limit of signum of x when x approaches to 0. And in the second case, we have to find limit x tends to 0 minus, and here we have signum of x. So again, here we have to find out the left hand limit of signum of x when x approaches to 0 from the left of x is equal to 0. And in the third problem, we have limit x tends to 0, and here signum of x. So we have to find out, or we have to check whether the limit of signum of x it exists when x tends to 0. So we can draw the conclusion regarding this limit, or regarding the existence of this limit, by the first two cases, right? And in the fourth problem, we have limit x tends to 0, and here we have the absolute value of signum of x. So let us find out the limits, and before finding out the limits, let us first quickly see the definition of signum function and the graph of signum function. So now let us consider the function y is equal to f of x, which is our signum function. So this is defined as positive 1 whenever x is greater than 0, and signum of x is 0 whenever x is 0, and signum of x is minus 1 when x is less than 0. So for all positive x, that is x greater than 0, signum of x takes the value that is plus 1, and for x is equal to 0, signum of x is 0. It implies that signum of 0 is equal to 0, and for all negative x, x less than 0, signum of x takes the value minus 1, right? So here we can now write f of x, which is our signum function. So we have f of x is equal to 1 for all x greater than 0. F of x is equal to 0 when x is equal to 0, and f of x is equal to minus 1 when x is less than 0. So here we have the line y is equal to 1. Here we have y is equal to 0, and here we have y is equal to minus 1. So we can now here draw the graph. So this is x-axis, this is y-axis, and here we have plus 1, and here we have minus 1, right? So for x greater than 0, so for this region, that is the positive x-axis, we have y is equal to 1. So y is equal to 1 is the line which is parallel to x-axis, right? So this is our line y is equal to 1, and y is equal to 0 for x is equal to 0. So here we have the point that is 0 comma 0, and here x is greater than 0. So here we cannot include this point, so here we can encircle it, and here we have y is equal to minus 1. So y is equal to minus 1 for x less than 0. So here we have the line which is parallel to again x-axis, and here this point is not included. So this is our line y is equal to minus 1. So this is the graph of signum function. So now let us find out the first limit. So here we have x tending to 0 positive. So this is the right hand limit of this function when x approaches to 0. So to get the value of this limit, we can now substitute here x is equal to 0 plus h, because here we have to take all the values of x which are greater than 0, and here obviously h is infinitesimally very small, right? So x is equal to 0 plus h, that is simply h, and when x tends to 0, then h also tends to 0. So now the right hand limit can be written as limit, and here we have for x tends to 0 positive, we have h tends to 0, and here we have signum of x is h, right? And here as we have just said that h is infinitesimally very small, but h is greater than 0, that is h is a positive quantity, right? So whenever h is a positive quantity, that is when x is greater than 0. So when this input is positive, that is greater than 0, then signum of h should be equal to 1. So signum of h is equal to plus 1 due to this definition. So whenever the input is a positive number, then signum of that input takes the value positive 1. So here we have limit h tends to 0, and for signum of h we have plus 1. So here this quantity is now independent of h, so we can remove this limit notation, so we are left with just plus 1. So the value of this limit is equal to plus 1, and similarly we can find out this limit, that is limit x tends to 0 negative, and here we have signum of x. So this is basically the left hand limit of this function signum of x when x approaches to 0 from the left of x is equal to 0, and when we have evaluated the right hand limit, then x approaches to 0 from the right of x is equal to 0, and in the neighborhood of x is equal to 0, we are considering 2 points, that is this point is 0 plus h, that is h, and now we'll take here x is equal to 0 minus h. So this point which lies very close to x is equal to 0, but it lies towards the left of x is equal to 0. So we have x is equal to 0 minus h, and this is minus h. So when x approaches to 0, then h tends to 0, and h is obviously greater than 0, it is infinitesimally very small, and h is a positive quantity. So now the left hand limit can be written as limit, and for this we have h tends to 0, and here we have signum of minus h. Now see here the input is a negative h, but h is positive. So h is positive, so minus h is negative, that is minus h is less than 0. So here the input is a negative number, and in that case here we have h, so this is a positive input. So when we have x less than 0, then signum of x is minus 1. So signum of minus h is equal to minus 1 due to this definition. So here now this limit is the limit h tends to 0, and here we have minus 1. So now again we can remove this limit notation. So omitting this limit notation, we have simply minus 1. So the value of this limit is minus 1. So now from these two limits, we come to the conclusion that the limit of the function, that is signum of x, it does not exist, right? So it does not exist because when x approaches to 0, then the right hand limit and the left hand limit are different. although the right hand limit and the left hand limit, they exist and they are finite. Right hand limit is plus 1, left hand limit is minus 1, but the two limits does not converge to a common point, right? So this limit, that is limit x tends to 0, signum of x does not exist. So when we go by the definition of the existence of limit of a function, then we see that the right hand limit should be equal to a left hand limit, right? But in this case, the right hand limit and left hand limit are different. That is, plus 1 is not equal to minus 1. So this limit, it does not exist. So now here we write this limit does not exist. So now let us come to this fourth problem. So here we have limit x tends to 0 and mod of signum of x, that is the absolute value of signum of x. So to find out the existence of this limit, let us find out the right hand limit first. So right hand limit is given by limit x tends to 0 positive, and here we have mod of signum of x. So again we'll follow the same steps, and here x is 0 plus h tends to 0 when x tends to 0, and h is a positive quantity and infinitesimally small. So here we have limit h tends to 0, mod of signum of x is 0 plus h, that is h. So here we have h. So we have now limit h tends to 0, and signum of h takes the value plus 1. So here we have plus 1, and here we have mod of plus 1 is simply 1. So the right hand limit of this function when x approaches to 0 is plus 1. Let us now find out the left hand limit, and here we have limit x tends to 0 minus, and here we have mod of signum of x, and again we'll follow the same steps. X is equal to 0 minus h, that is minus h tends to 0 when x tends to 0, and h is greater than 0, and minus h is less than 0. So we have here a limit h tends to 0, and here we have mod of signum of x is minus h, and we have just seen that signum of minus h is minus 1. So mod of minus 1 is simply plus 1, right? So in this case we see that the right hand limit and the left hand limit both are finite and they exist, and moreover both the limits are equal to each other, right? So the right hand limit is equal to left hand limit is equal to plus 1. So this limit has the value plus 1. So the value of this limit is equal to plus 1. Now here it is important to note that although the limit of this function it exists and it is equal to plus 1, but this function, that is a mod of signum of x, is not continuous at this point, that is x is equal to 0, because a function is said to be a continuous function if the right hand limit is equal to left hand limit, and both these limits should be equal to the value of the function at the given point, that is the point of consideration. So here the point is x is equal to 0, that is a is 0. So let us find the value of f of a, that is f of 0 for this function. So here we have mod of signum of x. For x we write 0, and from the definition of signum function we know that when x is equal to 0, signum of 0 is 0. So here we have mod of 0 is equal to 0. So the value of the function at this point is 0, and 0 is not equal to plus 1, right? So the limit x tends to 0, mod signum of x is not equal to f of 0, because if the limit is equal to the value of the function at the given point, then only the function is said to be continuous, right? So here the condition, this condition is not fulfilled by this function. So limit is not equal to f of 0, hence this function is discontinuous at x is equal to 0.